Hey everyone! As our customers know, our machines are very capable of achieving and sustaining high-speed production, especially when combined with professional CAD/CAM software such as Fusion 360 from Autodesk. In this video, we're going to demonstrate how to get the most productivity from your CNC Router Parts machine and Fusion 360 by understanding and managing your CAM tolerance and smoothing settings. Let's start by comparing two programs. Both identical, including a 450 IPM feed rate, except the first one, Program A, I'm using a default tolerance and I've left smoothing off, as it is by default. And in the second program, Program B, I've set the toolpath tolerance to a more practical value, 1/1000th of an inch, and enabled smoothing. And let's watch that one more time. Program A, see it's very slow, and Program B, see we're about twice as fast now and much smoother. Okay, before we talk about how tolerance and smoothing affects machine G-code, let's talk briefly about the two basic movement commands. The first are linear moves, such as G0 rapid or G1. For these, the machine will move in a straight line directly to the coordinates you or the CAM program specify. The second are arc moves, such as G2, G3, which is a similar syntax to linear moves, except for you or the CAM program will also specify the radius that the machine should follow. This will create a smooth curve that would otherwise take hundreds or thousands of linear moves to approximate, depending on your tolerance setting. With that, let's move on and talk about the considerations the CAM engine faces when deciding how to generate G-code for our design. I've created an arbitrary curve similar to what we'd find on one of the Pac-Man ghosts, and I'll use T-spline fit points to illustrate three representative scenarios and talk about the trade-offs. First, let's create a polyline with 5 data points to represent how a very loose tolerance setting would fit a series of linear movements to our ideal geometry. Clearly, this hypothetical CAM solution would result in significant deviation from the ideal curve between the nodes and would create a great deal of prominent fastening, which would be apparent in the finished quality of the part. That said, the program would likely run very quickly compared to a program that has more movements and the same amount of work area distance traveled. So this scenario for us will represent a likely very efficient but also inaccurate CNC machine code scenario. In my second example, I'll use twice the amount of data points to fit my linear moves to the curve, and this will represent our tight tolerance scenario. In this case, we've dramatically reduced the amount of deviation from our ideal curve, as well as reduced the faceting. As you might expect though, depending on the scale, this could have an equally dramatic effect on the productivity of the machine, as the amount of linear movement code per work area distance has doubled. At small enough scales, these very small moves can result in excessive movement data, which will slow the machine down and cause the jerky motion we saw earlier in the video. As you might expect, the third example is what I'll call the happy compromise. Here we have a relatively tight tolerance, but we've also enabled smoothing, which will use the ideal geometry data as input to generate optimized G2 arc movements instead of linear movements, which can have a dramatic impact on the productivity of your CNC machine and the quality of the finished final part. Now let's look at how we affect this change in Fusion 360. I'll start by creating a new 2D contour operation and select the outline profile of each of my Pac-Man characters. We can also now see the feeds and speeds, and note that the feed rate is set to 450 IPM. Switching to the Passes tab, we can see the tolerance setting. And just a quick word about these defaults. You'll create outstanding G-code from Fusion as long as you remember to manage your feeds and speeds on the first tab and the tolerance and smoothing settings on this tab. Always ensure that these settings are not left at default values, which are often optimized for steel machining in traditional low IPM CNC mills. Let's change the tolerance to match our machine, in this case 0.001 or 1/1000th of an inch, and enable smoothing. And this is where things can get a bit counterintuitive. But generally speaking, the tighter your tolerance is, the more data the smoothing feature will have to generate good arc fitments, and that should not slow down your machine. The upshot of this is that if your machine is not hitting your program feed rate and you're using smoother and want to tune further, try adjusting the smoothing tolerance, making it looser, while leaving the overall tolerance field at the top tight, in this case 1/1000th of an inch. With the tolerance updated and smoothing enabled, I'll generate the G-code for this program, and we can compare it to the G-code I generated earlier using the default tolerance value with smoothing disabled. As you can see, the G-code for this operation is significantly smaller, which, everything else being equal, is great news for productivity. You can make future projects that much easier and more consistent by curating your own tool library. In fact, Fusion makes it easy to drag and drop tools from your current project into your permanent cloud library, where you can customize your default feeds and speeds and other tool parameters. Likewise, you can save toolpath operations you use often as templates, where settings such as tolerance and smoothing and a whole bunch of other settings can be optimized and used over and over again. Since you're storing these in the cloud, they'll be available on any computer you log into. Let's compare these two programs again in a bit more detail and talk about some of the more subtle but important clues that our program might benefit from tuning Fusion tolerance or smoothing settings. One symptom you may notice is perhaps your program is only averaging a fraction of your program feed rate, such as program A in the right hand corner. This could be because you miscalculated your feed rate. However, in many cases, such as program A, it may well suggest that you have excessive data and would gain machine productivity from reducing it, either by cleaning up your project sketch or model and ensuring it doesn't have excessive sketch points or polylines that could be arcs, loosening the toolpath tolerance, or better yet, as we've shown here, by using smoothing to turn those linear moves into more efficient arc moves. Here's a screen grab of the operator console after each program executed. You can see that program B on the right was significantly faster, 64% in fact, and resulted in a better part finish. This is obviously a simple example project. However, in cases such as this where there are few mechanical clearance or tolerance requirements, we could have tuned it quite a bit further with a higher IPM and more aggressive smoothing. In conclusion, our recommendations are that you set your tolerance, enable smoothing, understand the relationship between tolerance and productivity, and know that your overall tolerance with smoothing enabled is effectively the sum of both values. This was a fairly long video for what amounts to one checkmark, and hopefully you have a sense for what the tolerance and smoothing features do in Fusion, and our hope is this will empower you to create more productive programs with this powerful 3D CAD/CAM tool. As always, thanks for watching, and be sure to check out our website and subscribe to our channel to see more videos and sample projects.